Hello guys, welcome back to VC Tech. In today's tutorial, we'll be talking about switches and VLAN. In computer networking, switches and VLAN play a crucial role in how data is managed, segmented, and also transmitted across local networks. Understanding this concept helps you see how networks are structured in a real-world organization. And also for this tutorial, we will be using Cisco Packet Tracer for the configuration of VLAN and also assigning ports to VLAN. Having said that, let's head over to what is a switch. A switch is a network device that connects multiple computers or laptops or devices within the same local area network. It operates at the data link layer of the OSI module, and it is also responsible for forwarding data only to the specific device that needs the data. Unlike a hub, which sends data to all connected devices, a switch uses a MAC address to identify the correct destination of where it's supposed to send the data. By doing this, it reduces unnecessary traffic and improves network performance. How does a switch work? Imagine you have three computers connected to the switch. You have PC1, you also have PC2 and PC3. So when PC1 sends a message to PC2, the switch reads the destination MAC address in the frame, and it then forwards the data only to PC2 port. PC3 will not receive that message because PC1 was not trying to send the message to PC3. This makes communication efficient and secure within the local area network. Now let's talk about what a VLAN is. A VLAN is a virtual local area network. It is a logical subdivision of a switch network. It allows network administrator to separate devices into different broadcast domains, even though they are on the same physical switch. For example, in an organization, the HR department and the finance department and the IT department might be connected to the same switch. But using VLANs, their traffic can be logically separated. HR could be assigned as VLAN 10, finance could be assigned as VLAN 20, and also IT could be assigned as VLAN 30. By doing this, you will improve network security and also reduce unnecessary broadcast traffic. And why is VLAN actually important? VLAN is important because it offers us security, good performance, flexibility, and also efficiency. Security being devices in different VLAN cannot communicate directly unless a router is used. It provides better network isolation, while for performance, VLAN reduces broadcast domain, which minimizes the network congestion. Also for flexibility, devices can be grouped logically rather than physically, making it easier to manage large networks. Efficiency, troubleshooting becomes easier as administrator can control which traffic flows when. So with that being said, let's head over to Cisco Packet Tracer, where we get to configure VLANs and assign ports to VLAN. So this is a switch. The switch comes with 24 ports and 2 gigaports. As you can see, 24 ports and 2 gigaports. For this video, we will be making 3 VLANs. As you can see, we have VLAN 10 for HR. I'm also going to show you how this was created. So VLAN 10, we want to name this HR. VLAN 20, you want to name this PIN, and VLAN 30, you want to name this IT. Let's also do show VLAN, check. So as you can see, we have VLAN 10, VLAN 20, and also VLAN 30. And if you look properly, the ports, all the ports are in the default VLAN 1. No ports have been assigned to VLAN 10, 20, or 30. Why no port are being assigned, let's test for communication and see if the devices on the switch can communicate. I've already assigned IP address to the host laptops. Now let's ping for communication. Ping 192.168.1.4. Now as you can see, we are getting a response. So this is 192.168.1.2, and this is 192.168.1.3. this one takes .4, this one takes .5, this one takes .6, and this one takes .7. So let's use this PC to ping all the laptops in the network. So let's ping .3, and .3 is reachable. There's also ping .5. .5 is also reachable. Let's ping .6. .6 is reachable, and lastly let's ping .7. And as you can see, we are able to ping all the PCs in the switch. We will be using this PC later on after we've assigned ports to VLAN. Alright, so we can do that by doing interface range. And now for this one, interface FA0/1 and FA0/2 will be taking HRO VLAN 10. So interface range FA0/1 to 2. And you want to say switch port mode. Switch port mode access. You also want to say switch port access VLAN 10. So by doing this, we've assigned interface FA0/1 and interface FA0/2 to VLAN 10. Let's also do the same for the other interfaces. So we say 3 to 4, and switch port mode access, switch port access VLAN 20. We've also assigned FA0/3 and 4 ports to VLAN 20. Let's do for the last one, so 5 and 6. Switch port mode access and switch port access VLAN 30. Now we've created VLAN and we've also assigned ports to the VLAN. Now let's check let's do show VLAN once again. And as you can see, previously we had no ports assigned to any VLAN, but now we have FA0/1 and 2 for VLAN 10, as well as we have 3 and 4 for VLAN 20, and also 5 and 6 for VLAN 30. Now let's try to test for communication and see if we are able to ping the devices that are not in the same VLAN. First of all, we are going to ping the device that is in the same VLAN with us, which is .3 network. Is this device 192.168.1.3. So if we ping this, definitely we would have communication because they are in the same VLAN. Now let's also try to ping VLAN 4 and let's see what happens. We won't be able to ping VLAN 4 because we are not in the same VLAN, as the VLAN is meant to isolate networks, isolate IP address in the same VLANs. So we won't be able to ping 192.168.1.4 because it's in a different VLAN. It's in VLAN 20. As you can see, this is 192.168.1.4. Let's also try to ping network. Let's ping .5 IP. As you can see, guys, it's not going to work. We can't be able to ping any IP address that is not in the same VLAN with the PCs. So for these two PCs can communicate because they are in the same VLAN. These two also can communicate because they are in the same VLAN, as well as these two can communicate because they are in the same VLAN. Let me also try to ping from this device to .5 network and see if it connects. It's supposed to connect because they are in the same VLAN. So as you can see, we are able to ping .5, but we won't be able to ping .6 since .6 is in a different VLAN. So this is how VLAN actually works. It segments networks, even though they are connected to the same switch. It just segments the network to avoid congested traffic. Thank you guys for watching this video. If this video helps you to understand what a switch and a VLAN is, I would like if you like and subscribe to the channel so you could gain more knowledge about networking. Thank you and see you in the next video.